we always liked the old ship game demo, but it felt very dated. So we decided that we needed to make a more advanced 3D game demo for MonoGame. So let's start by actually showing the demo and go from there. Just running it straight from Visual Studio. Now, I guess I can full screen it. I don't know. Let's see. We'll see. So we're kind of renaming this demo Ascent. I don't know if I can full screen it, actually. I think it's not even set up for that. Yeah, it's not set up for full screen, so we'll have to deal with this for right now. This is basically the ship game demo, but we've made some pretty big changes, especially in the internals. So let's just start with like that first level that everybody knows. So the first thing you'll notice is that the lighting is different. And that's one of the main things that we started with. When we looked at the ship game demo originally, the biggest problem was that the lighting was pretty bad. You know, it used a multi-pass rendering technique. So it would basically use basic effect, or actually it used a custom shader, but it would use it in multi-pass. So for every light on every mesh, it would basically render the mesh several times in order to accumulate lights, which kind of gave you a hard limit on how much lighting you could apply to the thing. Also, there was no shadowing of any kind. It was pretty bland. So here you can see we actually have some shadows. If I move the ship up here, you should be able to see a shadow here. Oops. You can see I have a shadow there of the ship. You can see the ship there. I don't know why I'm not using that. You know, we've also made some other little changes in here, but you can see we actually have shadows with it. We have lights. We have lights from all of the from shooting. We have lights, plenty of lights. This is still using just a regular Lambertian, lighting model or Phong model. It's not using anything advanced at the moment, but we're working on that. It's mostly just a content issue. So we have plenty of lights. You can see shadows there. We also added in actually, let's go to the other level first too. So you can kind of get a basic idea of, what we're doing here. Better lights and shadows and rendering techniques. It's a new shader for doing this, and I'll get into the details of that in a little bit. So let's just go back to the next level. So here's this other level that was this is all content from the original demo. Nothing very different here. You don't notice it at first, but there's shadows on everything. So you can see a shadow there. You can see shadows over here. There's like a light shoved in here, so you can see some shadows spilling out this way. As I go through these tunnels, you can kind of see, some different lights and shadows through here. See my ship shadow flying around here.
And the glow, of course, Tom. All the glow.
Yeah, I'm not super impressed with the glow. It's pretty basic. So to show you,
step up from the original, though.
Yeah, it's from the original. I mean, this content was actually fairly high quality for the time. This demo is like very old at this point. It's over 10 years old. But the demo quality of the content wasn't too bad. It had a good normal map. They tried with techniques at the time, specular and glow, to get some kind of effect here, and you get something, but it's not as good as it could be with modern built content. So you can see you have a nice specular there and stuff. Now this demo originally, there's basically in this demo there's basically one light in each level. There's one light in the center of this level and then one light in the other, because they couldn't really push it much further than that. So here I'll show you. So the other thing that we added in here is we added a built-in editor. So it looks kind of crappy at the moment, but it's a work in progress. So you can see that there's more than one light in here now. There's a bunch of lights. In fact, if I come out of the editor, you can see there are 34 lights in this scene with, at the moment, 26 visible, 34 of them are shadowed. It's currently updating 8 shadowed lights, more than we'd like, but it's doing, a lot of work there. You can see there on the screen is the shadow atlas that has all the shadows for the scene. So as you fly around, and you see a shadow, it's coming from one of these atlases. That's a shadow from that pickup there. In real time, and as you can see, it's reallocating all the shadows everywhere. This is not. It's funny. This is not really a new technique. Really, at the time that they made this demo originally, this technique could have been done. There's nothing special here that requires high-end hardware or anything. It's just the brilliant idea of instead of trying to render all your shadow maps to separate textures like traditionally people would do, just put them all in one big texture. That means that when you go render your lights, you don't need to bind a bunch of different shadow maps. You just have to bind one shadow map, and it has all your lights in it. Then it's just about, appropriately allocating them. As I'm flying around, you'll see that it's, you can see, like, if you look at this edge here, you can see it's a little aliased. There's a little PCF filtering there, but it's kind of like a really basic PCF filter, and it doesn't even work across shadow boundaries. But as I pull back, you can see that it'll change a little bit, or maybe it'll be hard to see because it's small, but actually it's pretty hard to see because it's kind of seamless. But as you're pulling away, and you can see it in the map a little bit, it's reallocating stuff. What it's doing is it kind of looks at the size of the light and how much shadow space it takes up, and decides to allocate smaller and smaller shadow maps as you're moving around. So you're really just rendering the highest resolution shadow map for the shadows that are closest to you. At a distance, it's automatically rendering lower resolution shadow maps. It's also doing some other stuff like, even though there are 34 lights in the scene, with 34 of them being shadowed, so every single one is shadowed at the moment. When I fire, the shooting ones aren't shadowed, but the other ones are. It's only updating 3 shadow maps right now, and that's because it's only updating shadow maps where there are objects that are moving. If an object isn't moving in the scene, it doesn't need to update the shadow map and keep using the old one. So that's another little trick here in how it's working, is only updating when it actually needs to update and not updating all the time. There's several other tricks that we haven't finished implementing that we started on but didn't get finished in time. One of them is, instead of rendering the shadow map instead of rendering everything every time when a shadow updates, you instead render the static objects first to the shadow. You keep that shadow map, and then whenever you need to update it, since the static objects never move, like the environment never moves, assuming the light isn't moving. If the environment never moves, you don't have to render the environment. You just have to render the dynamic things on top. So instead of rendering everything, you render just the dynamic objects that have moved in that light by using the previous shadow map with static elements already in it. So those are the kinds of tricks that we're applying here to kind of get a full set of shadow maps and lights. Also, the lights are a little bit interesting as well. I don't have a way to visualize them at the moment, but we're not doing it's not a constant buffer that has tons of lights in it, or there's no multipass here. It just draws everything one time when it does the thing. It's basically a forward plus renderer. So it's instead of embedding all the light data into constants and uniforms like you normally would, instead it embeds the light data into a texture. So there's a texture that's like 4 pixels, 4 pixels wide and 500 pixels long, that has all the lighting data for the level. It basically has the positions, the colors, the type of light, the shadow map index, all the data for every light in there. And when we go to render a triangle, it can look up all the lights and apply lighting to them. At the moment, it's not fully implemented, so it's currently, for every pixel in the scene, it's going through all 34 lights, which it does fairly efficiently, to say that, but it doesn't need to be doing that much, because of course, like, a light over here is not affecting a light way on the other side of the room. So the next stage of that is clustered rendering, which is it's become pretty popular in the last 4 or 5 years. Basically, you basically just voxelize the viewport, or the frustum. So you kind of have a grid across your screen of where all the lights are. You basically, on the CPU, you calculate the grid of where all the lights are on the screen. And this is in 3D, both width and height, and also depth through the scene. And you don't have to have a lot of grid points to do that, or a very big grid to do it. Once you have that grid, you then say, well, what lights are affecting this grid? And then you have a list of just these lights that affect the grid. Then what you do is you pass that information, that cluster data information, to the GPU, again via texture that just has data in it. And what it does is, whenever it goes to render a triangle, instead of going through all the lights, it says, well, what cluster is this texture in? Hey, Dom, can you hear me?
Yeah.
Yeah, can you mute your microphone? Because we can hear you.
Yeah, sorry about that.
So for every triangle, it takes when it renders a pixel, it says, well, what cluster am I in? Which is easy to do. It's simple math. And then from that, it can say, okay, we'll look up in the cluster map what lights affects this cluster. So instead of rendering every light in the scene, just render a couple. So this is not something we invented. It's something that's been around, since I think the first time I saw it was like 2014 or 2012. It was in some early papers. But the first kind of super AAA, I think, that actually did it was stuff like the Doom 2016 used this technique, which is now almost 10 years old. So this is not new stuff. It's a pretty common technique now, and it works. It doesn't require any special hardware. It doesn't require us to go beyond Shader Model 3. It's all very straightforward techniques. So this is a light version of that implementation. We're going to do more with it, including getting, like right now we just have, point light shadows, which are the more expensive one because you have to build a cube map. So all these shadows are cube maps for every one of these. So they take up, 6 slots. And you can kind of see that in the map as we're flying around here. But but spotlights are cheaper. They're just a single map. We haven't added support for that, but that's be fairly straightforward. I don't think we plan to do any directional lights because for what this game is, it's not necessary and it's not important. Again, we're building tech around this game and not tech for general purposes. This is not our goal is to build something around this game. So let's jump out of here and show you something else. So the other thing that we did is I was mentioning that we had an editor. That was because our plan with this demo is to give us enough stuff that we can actually build some more interesting content. Currently, this content is pretty. The content that's in there is pretty dated. So what we've decided is that we're going to build some new content in this demo. And what we decided to do is build it modular so that we can build a lot of different elements and very easily and put things together. So if I jump into the editor real quick, which is just the game, but shooting is disabled and you can fly around, but it's very primitive at the moment. We're going to do some more work to make it pretty. And this is using the GUM UI stuff, which is very easy to just add in. So you can come in here and select things and move them around. So I can come in here, my very rudimentary gizmo. So I can move this guy around. You can see how the shadow doesn't update because it doesn't see that that's a dynamic object. Even though it's animated, but it's static in place, so it doesn't know that it's animating. So until the player comes in here, it doesn't start updating the shadow. Those are little bugs and things that we're working on. So you can come in here and place all your lights in real time, and there's no problems with that. It's all real time and supported. So you can come in here and author things in a nice way. Tunnel doesn't go anywhere yet. This is just stuff that I was messing with since last night. You can come in here and change our light intensities, change our light radiuses if we want to. Oh, that's our scales right now in this demo are very big. It's kind of weird. The original demo was built at this really weird scale. Like this hallway is 500 units wide, which is kind of gigantic. So we're probably going to do some work to improve that. Let's see, what else did I put down here? Oh yeah, I have some more stuff down here. Oh, this guy's broken. To fix him. So I can come in here and fix this guy. Oh, he's just rotated around. So I can select this guy and spin him around. Actually, I think it's just that. Yeah. There's a little bit of problems we have with our Euler to Quaternion and back kind of transforms that we need to work out. Had some more stuff in this demo. Where was it? Oh, it's down there. Another one that spun around. Gotta fix that guy. I think if I just, yep, that does it. So yeah, very basic editor, but all we really need to kind of show off this work. The plan is to decorate this stuff out. This is currently just prototype pieces. We're going to make some more pieces that are a little bit more interesting. Like I think somewhere in here we had, since I'm in editor mode, I can fly anywhere. Somewhere in here we had like up angled piece. I'm gonna put him. I'm lost. Anyways, there's some more pieces that we're working on. There he is, but he's kind of misplaced. So we're building some more pieces like angles and T-junctions and four-way junctions in different size rooms. Eventually, they'll all be decorated out. We're moving to a physical base rendering kind of pipeline, so it's going to be diffuse textures with a metallic and a roughness material, so we can get a little bit better lighting effects out of this thing. And then that'll make things feel a little nicer than that. We currently haven't done anything for the ships and stuff like that, but our plan is to replace all this content. So yeah, that's basically what our current progress is. We've been working on this for roughly 3 or 4 weeks, something like that. So not a ton of work so far, but we've gotten some good results out of it. So let's go back to our slides, huh? It's enough demo mode. Oh, thank you for screwing that up. There you go. All right, so some of the things I already talked about. So why would we make this demo? Well, we made this demo because, there was there's always been this sentiment that MonoGame doesn't support 3D, and there was a lot of people that felt like, well, they don't know how to get into the 3D side of things. So we felt like we needed a good demo that shows how to do a 3D game that doesn't require you to write it from scratch, that is a starting point that inspires people to play, say, hey, I like that, but what if it did this and this? It's giving them something that's inspiring, that gives them some tech that works, that looks modern and new and has features that we expect. Our feeling was always with MonoGame is that we're not building engines here. We're building the core tech that you can build your stuff with, and we wanted to, prove that that's true. That's why another reason we built the demo is dog food MonoGame. This is where, we're making dog food. We want to eat our dog food and verify it's good dog food. We need to make sure that this works the way we expect it. And in this process, that's been really helpful is using MonoGame as is, like an end user would, and seeing what we run into. We also wanted this to be kind of turned into a starter kit at some point where you could easily either fork the repo or launch Visual Studio and create a new template from this project and then start modifying it, to fit your needs or to fit whatever game you wanted to do. We also wanted some fresh content. The original demo is really old at this point. It's very dated. And while it was high quality at the time, it could be a lot better. And, we need fresh content for MonoGame to kind of show off what it can do. So what have we learned so far in this process? Well, we definitely have issues with NuGets and versus source code. I've personally disliked NuGets. They seem to get in the way. They often don't want to work properly. The amount of times that I've gone and opened a project and tried to build and it said, give me some NuGet or .NET tool error that is unexplainable, that doesn't tell you how to fix it. And you have to you got to go to a command line or delete this folder or do this or do that or change that. That's all really annoying. And we're going to discuss more about how we can make that a less painful process. The other issue is, from my side, I come from building from source a lot of times. I avoid the NuGets if I can. If I'm building something rapid and I'm just kind of hacking something together, I'll use a NuGet because it's fine. I'm not worried about it. But if I'm building something I need to be working on for a while, it's something that we want to ship, we want to work from source code. And over the year, where MonoGame started it was very much work from source code kind of project. We did have an installer that gave you some DLLs, but that was the most of it. And then we've kind of evolved into NuGet delivery for everything and got rid of the installer and stuff. But in that process, I think we've damaged our ability to just build from source and run. So we're looking to make improvements there. That's one of the things we've learned just dogfooding our own stuff is NuGet and source code issues that have come up, and we're trying to improve those things. One thing I ran into immediately is we ran into some OpenGL issues. This current build was running on the Windows DX platform, but we're going to make sure that this runs on all the different MonoGame backends, and it should. It might have to reduce some quality, but it should. In that process, we found that the OpenGL side OpenGL builds the shader at runtime, not at build time in the pipeline. So for that reason, you can have shader errors when you go build your shader. You shouldn't, in theory, but in this case, the cross compiler we used to convert the HLSL to GLSL code generated bad code, and because of that, I had the experience of it spits out an error saying shader failed to compile, which doesn't really help you because it doesn't tell you, one, what shader failed to compile, two, what was the error? Like, why did it fail to compile? Usually when something fails to compile, it gives you a line number, what the error was, things like that. You didn't get that. So that produced this situation where it's like, wait a second, we have a problem here. So I kind of immediately went, and there's a PR that's already been submitted and merged that adds a real shader compiler, exception that gives you a real error message that tells you exactly what shader failed, what the profile was, what the line of code was that failed, the full source code for the shader, because you don't because of how the cross compiler works, you don't get the full source code unless you actually build for debug and dump that stuff. So it now gives you a real good error message when that occurs. It, in theory, shouldn't occur, but because of the nature of OpenGL and how it builds shaders at runtime instead of compile shader at runtime instead of ahead of time, this is possible. So having a good error message is good. So that was another thing. In part of doing this lighting work, I kind of found the need for some expanded APIs. That's something we're going to start discussing of where can we, and we've done this in the past, but we need to do a little bit more of it. For example, a convenient thing as part of, it might not be how we end up doing it, as part of trying to make the shadow mapping split its work into dynamic shadows and static shadows and reusing static shadow maps. It'd be very convenient to be able to copy from a shadow map to another part of it, to another shadow map, without having to involve the CPU, and just have it doing it on the GPU. Ideally, you could just say, hey, copy this texture from here to here. And there are APIs in the DX11 level. There's the APIs on DX12. There's APIs in Vulkan. I believe OpenGL has APIs for this. You can do that through extensions. That you can just do this copy and let the GPU take care of the work. That said, XNA never had an API like that. So it's one of those things where we should consider whether we need an API for doing these kinds of things. There's also a need for, currently the shadows are all being done as either a float 16 or a float 32 texture, which is common, that works. But it doesn't have to be. You can actually use the depth map to do your shadowing, and that gives you some advantages, like it automatically works with depth. It gives you all that you need. You don't have to have two maps. It's less expensive. Some hardware benefits for doing that. That said, there is no way in MonoGame to just render to a depth map. Every depth map is tied to a render target. There's no separate depth map. That's a place where we could potentially expand the API and make things a little bit better for more advanced techniques. While you can do this perfectly fine without it, it would be an improvement to do it. The other thing we learned in this was that we kind of went for adding a resource to the website. Like, if you guys haven't seen that, it's basically on the website. You can go to resources, and we have this resource list. This is actually turning out to be pretty good. There was at least a couple things that I came across just looking at this list. Not that it's comprehensive or big, but we want to continue to add to this, and I think that we want to improve this to make it better. There's some limitations with filtering and things like that, but the resource list is helpful because it kind of gives you a place to go when you're like, well, wait, how do I do this? I need a UI system for this. I need a lighting system. I need a collision system. I need physics. That gives you a place to go to find these pieces. Because our belief with MonoGame is that it isn't about an engine. It is about you building a custom game using custom tools that fit your game, right? Because that's a problem people run into a lot of times going to Unreal Engine or Unity from custom kind of tools. It's like, well, how do I fit what I want to do into this generic box? And it's difficult to do. Sometimes customized tools that are exactly the way you need them for your particular game make sense. In fact, a lot of times they make the most sense. It works the way that you want to work, the way that your game works. So that's what we're trying to achieve with this demo, is show that that's how you can build things like this. So for us, being able to integrate third-party tools in order to rapidly build out an editor and do those things is very, very flexible, and it is the right path, we think. So that's what we're trying to show with this, is that the idea with MonoGame is you take MonoGame as a core, you should be able to bring in some of your own code and third-party resources in order to build a bigger game. And all this also showed us just the flexibility of using C# and MonoGame. There was we did a lot of stuff very rapidly, with this, not just because we kind of know this stuff, but also just because it's a lot easier to work with, and it was fun to work with. It was more fun to do this than to find a C++ compiler and things like that. So there was a lot of things that we learned through this process. So, okay, why is that going? There we go. So what are our plans moving forward? So the first thing that we're doing with this is we're trying to aim up to what we plan to present on the next AMA, and what our next set of goals here are. One, we want to get the lighting better, so we're going to implement the full lighting cluster stuff. Two, there's no tone mapping of any kind in this game. Really, there wasn't any before. It just kind of like rendered to white. There was no HDR. So we want to add a tone mapper in there and allow just some light tone mapping and be able to at least be able to render to full HDR. Currently, the build is rendering to HDR targets, but there is no there is no tone mapping in there, so it kind of doesn't look as good as it possibly could. We want to add decals in there using similar technique to what Doom did, where you basically have a decal atlas. It's the same thing as Shadows. You have a decal atlas. You assign decals as you move around through environment. You copy your decal data to the atlas. Or you pre-load your atlas with all your decals as you need them. And as you fly around, it can then render decals on any surface very cheaply, because it's all baked into there. Decals are basically like spotlights, essentially, with the decal data on it. So that allows us to do a forward pass that renders decals and lighting all in one thing. The particle system that's in there, it's currently disabled in the build. It's broken. I haven't really spent time looking into it. But it also was very simplistic, and that's something we want to discuss and see if there's something we can do there to get a better particle system out of this. I was going to look and see, what I know that there have been some third-party particle systems out there. I haven't looked in a very long time. It's worth looking, and when we find some things, add it into the resource page so that other people can find them too. And then animation, there was basically, other than a spinning thing which was done in code. There's no real animation in this stuff, and we want to add some more animation into it. We have some props we want to use, and we want to add some animation just to the environment and to the players and enemies, as we get further into this. So those are all kinds of parts that we plan to expand on the renderer side of things. We also want to add some more editor features. Currently, the editor is just very simple, grid-based. There's no rotation gizmo yet. There's no scaling. We want to add a couple more things that make sense for our purposes. Particularly, we want to be able to build out the level fairly quickly. Currently, we're using a grid to kind of place things, but we want to have a snapping kind of system where you can snap a piece onto another piece and it knows how to automatically snap them together. We also want to look into a little bit more with, I guess we have all the core stuff for the editor at this point. I didn't mention undo, redo, cut and paste all works, delete, all the normal things you would expect. The property editor is fully functional, but kind of rough visually. There's a lot of visual elements in the editor we want to improve. That's just me getting and us getting used to the GUM UI stuff and how to best use it there. I guess looking audio system, we have an overhaul that we're going to work on. The original demo kind of played everything as 2D sounds because it was just everything from the point of view of the player. We're moving to a 3D system. We're going to stick to MonoGame audio and not do anything like Fmod for this demo, just because we just want to focus on MonoGame this demo. We can look at third-party solutions in the future. We also want to add some enemies and more gameplay. There's already been some work on adding some enemy AI in there. It's still in development. Hopefully there's more to show next month. And we're working on a complete art replacement. The image here on the side is kind of some concept art we're kind of working on kind of the direction that we're heading. Again, it's not going to look like this. If you ever looked at concept art books and then compared it to the games, concept art always looks much better than the games. This is aspirational and more of a vibe thing than a final look of the art. But we kind of want to go for like an alien mind kind of concept is kind of what we're going for. So very alien looking rocks and things and mining equipment and metal and parts and things. But also, we feel like it's a zero gravity environment. So a lot of zero gravity effects. We didn't get a chance to get into any physics in here. We have a physics engine implemented in there, but we haven't really done much with it yet. So we want to do some zero gravity things. So there's some exciting stuff we're working on with that, and we'll see how far we can get in the next 30 days. Back in our plus. So we also want to take some of our experience here and some of the parts that we learn in this process and some of the core tech in it and kind of break that into guides and tutorials and use that to kind of educate a little bit more on how things can work and how you would build stuff. We also want to support some of our new platforms. Currently, I'm just building it with Windows DX, but the plan is to get it up and running on the new DX12 backend that I think was recently merged. The Vulkan backend, which has been in there and it's gotten some fixes from some people, but it still needs more shaking out. We'll also make sure it runs on consoles. I believe that we can get this running on mobile even. It'll obviously take some compromises to, how many shadowed lights there are, the LOD of everything. But we're aiming our new art to be built in a way that looks high poly, but isn't high poly, and but is high poly enough to make it feel very good, and be able to use it across different platforms with just a reduction in quality of the per pixel quality and not necessarily geometric quality. And then after all this, and we get this done, our plan is to do more demos like this. Take something, this time we kind of work from Ship Game just because it kind of inspired us. But next time we have ideas for complete other demos that are just different games, different genres, different presentation that we want to do. And for each of those things, we plan to kind of start from a blank code base. We don't plan to bring all this code across and reuse it all or anything like that. Our belief is that, for every game, you kind of need to build stuff the way that the game needs it and not, well, how do I use this system and make this work, within this existing system. So we'll probably build new demos with new tech stacks so that just some variety and just shows different ways of approaching things. So what are our release plans for this demo? Currently, it's a private repo that we have, and we're going to make it available today to people that are on our Patreon and GitHub sponsors level, draw user primitives level, and above. So we'll give you access to the repo. You'll have access to a private Discord for the demo, and we kind of want people to jump in there and get involved. Like, give us suggestions, try it out, tell us what pain points you have. Heck, if you want to submit a PR, we'll take it. Just we want to kind of build this and make it a better demo and a better showcase of MonoGame, but within limits. We want to stay within what our guide rails are here. We're not looking to do a multiplayer game. We're not looking to ship this as a selling game or anything. This is going to be a public demo. All the content that goes into it will be publicly released later this year sometime. We don't have an exact timeline with that. And when we do, anybody can fork it, work with it, do whatever they want with it. The content will be basically free to use, just with MonoGame attribution and stuff. And that's our plans for the release. So yeah, at this point, I guess we can open to some Q&A with only 10 minutes left, but we'll maybe extend it. We'll see. But yeah, so if you want to get access to the demo, hit us up on Patreon or GitHub sponsors, and maybe even PayPal. I'm not sure. But you can go to the donation link on the MonoGame site. And once you sign up, you should be, I guess sometime after this talk, we'll start enabling all that for everybody.